Hello, and welcome to GP Podcast. Today, we're going to pull back the curtain on something fascinating, a research paper that quietly questions one of the most fundamental assumptions in all of modern AI. We're going to explore the single, almost invisible habit that has shaped how these incredible models learn, think, and even speak to us.
But what if that core habit, the very thing that unlocked this new world of powerful AI, has now become its biggest roadblock? See, this isn't about just making models bigger. It's about a radical shift in making them smarter by changing the very way they think.
Okay, let's dive right in. To really get what this new idea is all about, you first have to understand the old way of doing things. And it all comes down to a single process that pretty much every language model you've ever heard of has in common, from the early ones all the way to today's giants. That habit is called next token prediction. Now think about how an AI writes something. It doesn't actually grasp the whole sentence at once. Nope. It's more like it's playing a constant guessing game, just predicting the next tiny piece of a word, a token, and then the next one, and the one after that. This step-by-step method is, believe it or not, the backbone of almost all modern AI.
Now, this approach is powerful, don't get me wrong, but it's also incredibly inefficient when you really think about it. It forces these unbelievably complex models to just crawl forward one tiny fragment at a time. The source paper I'm pulling from puts it perfectly. It's like using a supercomputer to spell out sentences letter by letter. Kind of crazy, right?
And that inefficiency, which was fine when the models were smaller, is now causing a massive problem. The entire industry is starting to smack right into a wall. Let's call it the token wall. We're just throwing more power at the problem isn't the answer anymore.
I mean, we now have models with trillions of parameters running on these huge farms of GPUs. And yet, they are still fundamentally stuck taking these tiny steps forward. The models have scaled up beyond our wildest dreams, but the core task they're performing, well, that's barely changed at all.
And this leads to some very real-world problems. We're hitting hard physical and economic limits. Power grids are getting strained, the cost of GPUs is just astronomical, and that old solution of just throw more compute at it is quickly becoming completely unsustainable.
So this is where some fascinating new work from Tencent and Tsinghua University comes into play. They didn't try to build an even bigger model. Instead, they took a step back and asked a much deeper question. Why are we forcing our AI to predict such tiny, low information units in the first place? And their answer is a brand new architecture called CALM. That stands for Continuous Auto-Regressive Language Models. The key idea here is both incredibly simple and totally radical, and it represents a complete break from that old next token habit. So instead of predicting the next little piece of a word, CALM predicts the next vector. Just think of a vector as like a conceptual zip file. It's not just a string of numbers. It's a super compressed package of meaning that can represent multiple words or maybe even a whole idea all at once.
And the difference is just night and day. You see, traditional models predict one low-meaning token at a time, which creates these really long, clunky sequences. CALM, on the other hand, predicts one high-meaning vector at a time, making the entire sequence it has to deal with dramatically shorter. It's a complete change in how the AI is processing information.
So, you're probably wondering, how does this actually work in practice? I mean, how can a model just jump between entire chunks of meaning instead of these tiny word fragments? Well, the answer lies in this really clever compression and decompression process.
CALM uses something called an auto-encoder. What it does is it takes a chunk of text, let's say 4 tokens, and it squishes it all down into a single vector. The language model then does all of its work in this compressed space, predicting the next vector. Once it's predicted, that vector is then decoded back into the original 4 tokens with just incredible accuracy. We're talking over 99.9% in their experiments. So it's storing the same information, just in a much more efficient package.
So here's the kicker. Because the model is working with sequences that are 4 times shorter, the efficiency gains are absolutely massive. The research found that CALM gets similar performance to traditional models while using roughly 44% less training compute. Let that sink in. That is not a small tweak, that's a fundamental breakthrough.
And this speed isn't just from having shorter sequences. You know, a huge cost for AI is what's called attention. It's basically its ability to figure out which words in a sentence are important. This cost grows really fast with longer sequences, so making them shorter gives you a massive advantage. And on top of that, CALM uses a really lightweight, single-step generation process, which just keeps everything fast and efficient.
But this is about so much more than just efficiency and cost savings. This research could represent a huge philosophical shift in how we even think about AI cognition itself.
We are basically moving up the ladder of abstraction. Traditional models spend all of their incredible brain power predicting these very low information units, the next little piece of a word. What Calm suggests is that the future isn't about predicting the next word, but about predicting the next semantic unit, the next chunk of meaning, the next idea.
And this doesn't just make language models cheaper or faster. It fundamentally changes what a single step of AI thinking can actually hold. When each step carries more meaning, the model can reason and generate language in a completely different and potentially much more powerful way.
So this leads us with a really big question. Tokens. They were a necessary stepping stone to get us here, but this research suggests they might not be the final destination. Once you realize that an AI can operate on the level of ideas instead of just word fragments, it's kind of hard to unsee that potential. We might just be watching the dawn of a whole new era for artificial intelligence. If you like this explainer, please subscribe, leave a like, and comment on what you found most interesting. And of course, share it with anyone who you think might find this as fascinating as I do. Thanks for watching.